Okay, so we've got a garage sale Strife here, pretty good shape. It had batteries in it, so we know that it works, but we want to put some fresh Duracells in it, and let's clock it out, see what's going on here. Okay, 54, 71, 64, 56, 64, 64, 68, 29, 72. And it looks like that's all we got. So that was pretty stock performance there, 65 to 70 range. And let's see what we can do with her. Okay, got the batteries out. I've taken all the screws out. You notice there's two that are shorter, and those two go on that top rail for when we finally get back to putting this together. But let's see what's inside here. There's usually a post up in front here that gives you the most trouble getting out. So instead of a dart gate, we've got a plastic cover. There's a interlock here for the darts. It's usually there. That's already taken out, so I suspect somebody's been in here before. Let's get this guy ready for modifications. So, if you're not familiar with Strife, so rev trigger here. This is your battery negative lead with the resettable fuse. Let's see, put that in. Get the trigger come out. This is the jam door interlock, which must be engaged. This is the clip interlock, which must also be engaged. This is our trigger mechanism, which will come out here. Trigger has a screw. So usually on the inside of these, the screws are silver, where the externals are all black. There's that. We're going to need to take control of this guy. So again, there's another interlock right here, which requires a clip to be in before you can pull the trigger, and we're not going to need that anymore. We are, however, going to want to keep control. We're going to take control of the switch here, which will tell us when the clip's installed. So this comes out, which is the interlock. That stays in, which operates the switch. The switch itself, however, and a lot of times I'll just unsolder these, but since you're watching and we're trying to move fast, we're just going to clip these and then just put that back in place for memory. So now, yeah, in the stock Strife circuitry, the power flows from the battery through the rev switch, through the clip mag switch, and through the jam door switch, and then down under here through a wireway and to the motors. So it's going through an awful lot of components. If you do a wiring upgrade and you're using you upgrade your wires and then put in higher capacity switches here. I personally prefer doing the MOSFET route, as you guys are going to see. So again, we're going to just clip these guys off. We're going to be replacing all these wires, not necessarily with larger wires in the case of these switches, which are going to be signal wires, but just because we're going to have some connectors on there that. Okay, and if I can figure out how to get it back in place, well, we'll get to that. So this is the interlock that requires the rev switch to be pulled before the trigger gets pulled. So that wire's done. So the jam door switch is a single pole dual throw switch, which I think has something to do with the braking circuit. If you open up the jam door, they want to bring the motors to a stop as quickly as they can. We're only going to end up using part of that. So this polyfuse is interesting. So it will heat up if it's drawn too much current, and will open the circuit and then reset itself as it cools down. And it is set so that if your flywheel's jammed with a dart and you continue to hold the rev switch down, then this will open up to keep you from burning up your motors. And we're going to either reuse this one, which I think is 1.6 amps, or we're going to replace it with something a little higher, depending on what we're going to do with the Strife. We're going to initially start off, continue to use the AA batteries until we get the setup the way we want it, and then we will be we can go to IMRs or LiPo. Once we get things the way we want it, we know we can. Alright, so we're basically keeping our switches in place. Those are all going to be reused. And let's get our motor out here. Flywheel motors. Now these screws are black and a little bit longer, so we'll keep them separate. There's one of those. Pretty sure these are the same as the body screws. No, they're a little bit longer than the body screws, so they are a separate entity. These look like resistors, but they're actually coils, and that's to reduce the electrical noise. And since we're not going to try and meet any FCC requirements, and we're going to rewire all this with 18 gauge wire. So poly switch, we're going to save that. Wiring loom is out. The motor's ready to go. And let's, I think we're ready to begin our rewiring. So that's the basic internals of a Strife.